Okay, we're going to do questions 1 and 3. So for question 3, here's our differential equation. Here is the characteristic equation, and the roots we find are now complex. So our fundamental solution set the elements which correspond to complex roots are of the form e to the alpha x times cosine beta x, and then e to the alpha x times sine beta x, where alpha is the real part of the root and beta is the imaginary part. Since alpha in our case is 0, because we have 0 plus 3i and 0 minus 3i, we have e to the 0 times cosine of beta, which is 3x, and then e to the 0 times sine of beta, which is 3x. And of course, e to the power of 0 is 1, so we just have cosine 3x sine 3x as our fundamental set of solutions. So the linear combination of these is our general solution, and that is y equals c1 cosine 3x plus c2 sine 3x. For question number 3, we have a characteristic equation m to the power of 4 plus 8m squared plus 16 equals 0. And I chose to make a substitution where n equals m squared. So that leaves us with n squared plus 8n plus 16 equals 0. And this is easily factored, n plus 4 times n plus 4. And that gives us the roots in terms of n equals positive 4 and negative 4. No, n equals negative 4 and negative 4. So m, however, is the square root of n. So we take the square root of negative 4 and negative 4, and we're left with plus or minus 2i repeating one time. So our fundamental set of solutions, we already know how to deal with imaginary or complex roots, but when they're repeating, we then multiply e to the power of alpha times cosine beta x by x for one time per repetition of the root. So if this was plus or minus 2i plus or minus 2i plus or minus 2i, we would have the good old ordinary cosine 2x sine 2x, and then we would multiply that by x, and then we'd have x cosine 2x x sine x, and then we would multiply by x again, and that would add two more elements to our fundamental set of solutions, and that would be x squared cosine 2x and then x squared sine 2x. But this only repeats one time, so this is the entirety of our fundamental set of solutions. So the linear combination of these is our general solution, which is y equals c1 cosine 3x plus, oh man, copy pasting. Let's fix that real quick. Recompile. That is our general solution right there.